Now in this lecture we will discuss illustration of Kirchhoff law. So first we'll consider a single loop circuit. So the circuit is given here. So this is a single loop circuit. We have to calculate current in the circuit. So let us say what is the circuit contains. Circuit contains a battery, 6-volt battery. This is positive terminal, this is the negative terminal. It contains a resistor of 8 ohm, another battery of 12 volt and another resistor of 10 ohm. To solve this circuit, we have to first distribute the current. So distribution of current is the first important point. Distribution of current in the circuit. So let us say I have two battery, this one and this one. This is 6-volt battery, this is 12-volt battery. So this is a powerful battery. And we know current flows from positive terminal of the battery. So let us assume this terminal of battery sends a current I through this part. Now at this junction there is no bifurcation. So the total current will go through this wire. So this resistor will have current I, and when this current reaches here, once again there is no bifurcation. So this current, the total current will go through this part, and now this current will reach here, and similarly it will reach to the battery. One important point we have, battery always remains neutral. That is, if it sends current I, then it also gain current I. That is, battery always remains neutral. The same amount of current is thrown by the battery and the same amount of current is taken by the battery. Here also the same case, you have the I current is coming in and the current I that is going out. So battery always remains neutral. So now let us apply loop law from the Kirchhoff. So let us say we can start from anywhere. We can start from either point D or we can start from point C. We can start from any point. Let us say if I start from point B. So we are starting from B. So if I go from B to A, basically what we have a battery. And we are going from positive to negative terminal. There is a loss of potential. So we can say if I go from B, first I will have a loss of potential, that is minus 6 volt. Now if I cross this resistor, now I will go to A to D. So we have covered B to A. Now go from A to D. So if I cover this resistor, I am going in the direction of current. In the direction of current, there is a loss of potential, that is minus I times R. R in this case is 10, so minus 10I. Now if I cross this battery, basically there is a gain in potential because final is positive, initial is negative. So there is a gain in potential and the gain is of 12 volt. So we have to write plus 12 volt. Now if I cross this circuit, that is this element of circuit, that is a resistor, once again I am going in the direction of current. I have to lose a potential and that is 8 into current is I. Now we have reached to the point B, so we have covered D to C and finally I am coming to B. So what is the Kirchhoff law? Kirchhoff law says sum of the potential changes in a loop is 0. So this is equals to 0. So from here we can solve. So this is 6 volt is equals to 10 plus 8, that is 18I. So from here I can write I is equals to 6 by 18, that is 1 by 3 ampere. So current through this loop is basically 1 by 3 ampere. Now next part we have what is the power delivered to each register and what is the power delivered to 12 volt battery. So we have to find power delivered through each register. So power delivered is I square R. So for register power delivered is I square R. Now for R1 I will have I square R1, and for R2 I will have I square R2. So let us say power delivered power through R1, that is I square R1, and I is 1 by 3, and we have R1, that is 8 ohm. So this is 8 by 9, and SI unit for power is watt. Now similarly we can calculate power through R2, that is I square R2, and I is 1 by 3 whole square, and R2 let us say we have 10 ohm. So this is 10 by 9 watt. We have to also calculate power through 12 volt battery. So power volt battery, and through battery power is given by formula V into I, and V is 12 volt and I is 1 by 3. So this is 4 watt. So power delivered through 12 volt battery is 4 watt.